So now in this video we're going to look at an op-amp circuit. I'm using the LM358 and there's two of them on the integrated circuit. We're using one out of two. Thanks to the negative feedback right there, direct negative feedback, whatever voltage we set at the non-inverting input will be the voltage at the output, because the voltage goes up and down as needed to make those two voltages equal. And it's trying to get to that voltage. So it's a unity gain buffer, a buffer because we got our signal there, and the op-amp is providing power, so it's not affecting the signal voltage. Unity gain means we got whatever voltage is here times 1 coming out. It's unity, but since it's an amplifier, that's because it has the current that's being provided coming from the op-amp, so it's all within the limits of the op-amp. And here is our circuit on the board. Positive supply to pin 8, negative supply to pin 4. Basic op-amp stuff. If you're using the LM358, other op-amps will have different pin layouts. The plus is right there. It's going to the trim pot, and it's about half of the supply voltage. I got 5 volts right there. We can adjust it, go all the way to 0, anywhere up about halfway there, or all the way up to the positive supply if we want to. But the output cannot output 5 volts right there. So we're just going to stick it right to halfway right there. It's probably like 3.5, maybe 4 volts that the output can provide when you have a load. And so yeah, output is top pin coming right down to the inverting input, as we mentioned before. And we'll zoom back. We have a multimeter right here. So with the multimeter, it's auto ranging. I set it to V to measure voltage, and I don't have to move the red probe for anything but high current. Very easy to use multimeter, but they don't really sell them anymore. You might be able to find it somewhere, but generally speaking, they're not available anywhere. So there we go, spot on. Half of the supply voltage out of 5 volts will be just a tiny bit lower because of resistance along the way. We got 2.5 volts, and usually I'm not that spot on to half of the supply voltage. And there you go. The output is the same. Now, in recent video, we looked at the bipolar junction transistors. When I attached the load, it threw off the voltage a fair amount. This LED, remember the anode, the long lead, has to go towards the positive supply. So it's where the resistor is down there. The cathode, the short lead, is up one spot where this jumper goes to ground. So you can have all kinds of stuff sharing a direct connection to ground right there. But yeah, there you can see it's holding that 2.5 volts really well. Let's see what our maximum voltage is. I'm going to turn the trim pot all the way up to 5 volts. We can look at that, and it looks like we're losing a speck due to some extra resistance. But yeah, like I said, I think 3.3 volts, or 3.5 volts I should say, is about the limit we have for the output. So there you can see I turned the trim pot down quite a bit, and it maintained. I'll try to go up a little bit above 2.5, 2.8. So yeah, it looks like our limit with this particular load is 3.3 volts, and I'll go back up to this. So yeah, you always have to work with the limitations of the component you're using. Without a load, okay, it looks like it's a little bit higher, but still more than a volt short right there. So yeah, that's it for this video. Again, you got to learn the limitations of components, how to overcome them and whatnot. The vast majority of my videos are trying to keep the basic topic as simple as possible for those that are mostly completely new to learning electronics. That's my main focus. So future videos I'll try to show ways to overcome weaknesses, but the vast majority of my demonstration circuits and stuff are intended for people completely new. So I'm just going to stick with the basics. So in any case, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.